Strategy 1, different training sets using random sampling with replacement. One ensemble strategy is to train different base learners by different subsets of the training set. This can be done by random resampling of a dataset, i.e., bagging. When we train multiple base learners with different training sets, it is possible to reduce variance and therefore error. Different ensemble strategies: A. Bagging, B. Random forest, C. Eta boost, and D. Voting. Strategy 2, different training sets obtained by random instance and feature subset selection. The combination of bagged decision trees is constructed similar to strategy 1 using one significant adjustment that random feature subsets are used, i.e., random forest. B. When we have enough trees in the forest, random forest classifier is less likely overfit the model. It is also useful to reduce the variance of low bias models, besides handling missing values easily. Strategy 3, different training sets using random sampling with replacement over weighted data. This ensemble strategy can be implemented by weighted resampling of the dataset serially by focusing on difficult examples which are not correctly classified in the previous steps, i.e., boosting. C. Boosting helps to decrease the bias of otherwise stable learners such as linear classifiers or univariate decision trees, also known as decision stumps. Strategy 4, different algorithms. The other ensemble strategy, i.e., voting, D, is to use different learning algorithms to train different base learners on the same dataset. So, the ensemble includes diverse algorithms that each takes a completely different approach. The main idea behind this kind of ensemble learning is taking advantage of classification algorithms' diversity to face complex data. Characteristic of different ensemble classifiers. Although ensemble classifiers have a common goal to construct multiple, diverse and predictive models and finally to combine their outputs, each strategy is carried out in different ways using different training sets, combiner or inducer. Table 2 summarizes the properties of different ensemble strategies, the popular algorithms under each category and pros and cons of each ensemble classifier. Characteristic of different ensemble classifiers.